Hello students, today we are going to continue our lecture on application of partial derivative. We had already done complementary goods, substitute goods, direct partial elasticity, cross partial elasticity. So our question is the production function. Production function करेंगे आज हम. आपको पता है production function जो होता है, it's a function of capital and labor, right? Is already given here. It's a function of capital, it's labor and capital. And ये क्या दिया हुआ है? This is a k to the power alpha, l to the power beta, e to the power a into k by l. जहां पर आपका a, alpha, beta all are positive constants. What is the question saying? You have to calculate. क्या calculate करना है आपको? Marginal productivity of labor, and you have to calculate marginal productivity of capital. This is ये आपका पहला पार्ट है क्वेश्चन का. और दूसरा पार्ट क्या है? You also have to verify the Euler's theorem. हम धीरे धीरे प्रोसीड करते हैं. मार्जिनल प्रोडक्टिविटी ऑफ लेबर कैसे कैलकुलेट होगा? अगर हम इस फंक्शन को विथ रेस्पेक्ट टू एल डिफरेंशिएट कर देते हैं, राइट, तो वी विल गेट मार्जिनल प्रोडक्टिविटी ऑफ लेबर. इस समय हमें कैपिटल को कांस्टेंट रखना होगा. एंड इफ वी डिफरेंशिएट दिस फंक्शन विद रेस्पेक्ट टू कैपिटल कीपिंग लेबर कांस्टेंट, तो हमें मार्जिनल प्रोडक्टिविटी ऑफ कैपिटल मिल जाएगा, राइट? सो व्हाट इज द फंक्शन? Q is equal to a k to the power alpha l to the power beta into e to the power a into k by l. We calculate marginal productivity of capital. This is delta Q by delta L. Right? What we do here? We differentiate with respect to labor, so our capital जो है वो constant हो जाएगा. ठीक है? So this is a k to the power alpha. Over here also it is a k to the power alpha. Then I copy this as it is e to the power a k by l, and I differentiating this part l to the power beta with respect to labor, right? Again we have differentiated this portion. We are left with this portion and this portion, right? Then I differentiate this portion e to the power a into k by l, leaving the other parts as it is, right? Again we differentiate what is remaining at the end, that is a k to the power alpha. We are applying which formula? U V W, right? Product rule of the differentiation. We are differentiating this, so what will be the result? This will be L to the power beta है, तो beta power आगे आ जाएगा, that is beta. Then ये -1 हो जाएगा, L to the power beta minus 1, right? And other things as it is, right? Again we differentiate this. आपको पता है कि डेरिवेटिव ऑफ e to the power x जो होता है वो e to the power x ही है. So ये जो है वो ऐसे ही रहा, right? And this is e to the power x, so this is again e to the power x. By according to the chain rule आपको you need to differentiate this. आपको ये differentiate करना पड़ेगा because there is portion of labor over here, right? And we are differentiating with respect to labor. So you differentiate this, you will be getting minus ak by l square, and this is constant, so this becomes 0. So this is 0, right? Now what you have to do, you write these terms, arrange them. Now you take out the commons. You see what are the commons. A k to the power alpha, we wrote here. Over here also we have a k to the power alpha, we write this a k to the power alpha. We have e a to the power k by l Also we have here e to the power a into k by l. We take out the common, right? Over here we have L to the power beta minus 1. Over here we have L to the power beta. We take out the common L to the power beta, right? Fine. And we open the brackets. Whatever is left we write within the brackets. This will be beta minus this will be A into K by L, because we had this L to the power minus 1 remaining over here. So this is what we got here. Similarly, we calculate marginal productivity of capital. जब हम ये calculate करेंगे तो हमारा labor constant हो जाएगा, मतलब labor will be constant. So this will be delta Q by delta K. Again we follow the same method and we differentiate, right? This as we have done before, right? What we get over here is this is the result. Now again we take out the common, and what we do, this will be A into L to the power beta into e to the power A into K by L into K to the power alpha minus 1. Within the brackets we get alpha plus AK by L. You have to take out the commons from here. Just look at the terms very carefully while taking out the commons. This I have explained you here, right? Now the second part of the question is you have to verify the Euler's theorem. For the verification of the Euler's theorem, first you have to calculate the degree of this function. How do we calculate the degree of the function? We multiply the variable of this function with lambda, right? This will be L, labor is a variable, capital is a variable. So we are multiplying this with lambda, right? And this was the function given to us, multiplying k with lambda, multiplying L with lambda. Over here also we multiply k and L with lambda. So it is being raised to the power alpha over here, because it is given in the question. This is raised to the power beta over here, right? It is given in the question. Now what we do, we open the brackets. So what we get, this is A alpha, this is lambda to the power alpha, right? This will be k to the power lambda, to the power alpha, right? And this will be lambda to the power beta. This will be L to the power beta. We cancel this out, lambda. We'll be left with e to the power a into k by L. Now you see the base is same over here, so the powers will get added. So this is a as it is. This will be lambda alpha plus beta into k to the power alpha, L to the power beta, and e to the power a into k by L, right? We take this out. Why? We take this out, and whatever is left we write within the brackets. What is left? A, k to the power alpha, L to the power beta into e to the power a into k by L. You see, this is what we got here is same as this function, the original function. So now you see, lambda to the power alpha plus beta is same as the function, that is which is a function of labor and capital, right? It means what is the degree of the function? The degree of the function will be alpha plus beta. We have got the degree of the function. Now what is our objective? We have to verify the Euler's theorem. In order to verify this Euler theorem, we have already done this. How do we verify it? We verify it by this formula. Labor into this, what is this? Marginal productivity of labor plus capital into marginal productivity of capital is equal to the degree of the function into the original function, right? This is also n into q, that is n into z, whatever the function is, right? So we have to substitute the values over here. Whatever we have got now, we have got these results, right? Delta q by delta L and delta q by delta K. We have got these results. We need to substitute this and we have to prove that this is equal to this, right? Now we substitute whatever results we have got in step 1, we substitute it over here, plus this is delta q by delta K. We substitute it over here. Now you see, you have to take out the commons. I took out the common and cancel this out. You will get, when you calculate it, you will be left with this. That is alpha plus beta into q. Hence the Euler's theorem is proved. Right? This is the topic of production function. Now within this we have diminishing returns to factors, right? And we have returns to a scale. Returns to a scale. Right? What is diminishing returns to factors? It is the same as law of diminishing returns to factors. What does this mean? When we add more of a variable factor to a fixed factor, our total output increases, but it increases at a diminishing rate. मतलब जब भी हम कोई वेरिएबल इनपुट को इंक्रीज कर रहे हैं and our second input is fixed, suppose हम लेबर को बढ़ाते जा रहे हैं और हमारा कैपिटल फिक्स है, तो हमारा जो टोटल प्रोडक्ट है वो इंक्रीज तो करेगा बट वो एक डिमिनिशिंग रेट पे इंक्रीज कर रहा है. दिस इज नोन एज लॉ ऑफ डिमिनिशिंग रिटर्न्स टू अ फैक्टर, राइट? लेट अस रीड दिस. हियर total output of a commodity is increased by adding units of variable unit, right? While the quantities of other inputs are held fixed. हमारे पास दो ही इनपुट्स है यहाँ पे, एक तो लेबर है और एक कैपिटल है. अगर हम वेरिएबल यूनिट लेबर को मानते हैं तो हमारा लेबर बढ़ रहा है मगर हमारा कैपिटल फिक्स है. So the increase in total production becomes smaller and smaller after some point. टोटल प्रोडक्ट इंक्रीज तो कर रहा है बट रेट क्या है उसका, डिमिनिशिंग रेट पे इंक्रीज कर रहा है, right? The law of diminishing returns states that as additional units of a variable input, variable जो vary कर रहा है, are added to a given quantity of fixed input, the MP, the marginal product of the variable input, will eventually decline. This is what diminishing returns to factors state. यहाँ पर एक fixed फैक्टर ऑफ प्रोडक्शन है और उसके ऊपर पे हम एक ही इनपुट को हम वेरी कर रहे हैं, उसको बढ़ाते जा रहे हैं, राइट? एंड व्हाट इज रिटर्न्स टू स्केल? रिटर्न्स टू स्केल जब हमारे पास all the factors become variable, right? When firm increases the output by increasing more of all inputs, right? Relation is of scale. This is known as returns to scale. Now returns to scale can be constant returns to scale, increasing returns to scale and decreasing returns to scale. Constant कब होगा? जब आपका आउटपुट उसी प्रोपोर्शन में बढ़ रहा है जिस प्रोपोर्शन में आप अपने इनपुट्स को बढ़ा रहे हैं, वो कांस्टेंट रिटर्न्स टू स्केल होगा, राइट? जब आपका आउटपुट it is increasing more than proportional, right? That will be increasing. जो रेट है आपके आउटपुट का इंक्रीज करने का, your output is increasing more than the proportional proportionate increase in inputs. This is known as increasing, and decreasing is opposite to this. When increase in output is less than proportionate, then this is known as decreasing returns to scale, right? So look at this question. The production function for a commodity is, you are given a function Q, that is quantity, that is equal to 10L minus 0.1 L square plus 15K minus 0.2 K square plus 2 KL, where L is labor, you know, K is capital, you know this, and Q is the production, right? This is a production function which is given in terms of both labor and capital. Question क्या बोल रहा है? You have to calculate the marginal products. You have to calculate the marginal products of the two inputs when 10 units each of labor and capital are used. इसका मतलब आपको MPL निकालना है और NPK निकालना है, right? ठीक है? Now what is the second question saying? If 10 units of capital are used, what is the upper limit for use of labor which a rational producer will never exceed? मतलब अगर हम सिर्फ 10 यूनिट कैपिटल को यूज कर रहे हैं तो मैक्सिमम लेबर जो है, लेबर का कितना यूनिट्स यूज किया जाएगा, उससे ज्यादा प्रोड्यूसर, एक रैशनल प्रोड्यूसर एक्सीड नहीं करेगा. These are the two parts of the question. Now come to the question. You are given Q is equal to 10L minus 0.1 L square plus 15K minus 0.2 K square plus 2KL. We differentiate, we calculate marginal productivity of labor, जहाँ पर K आपका constant रहेगा. Delta Q by delta L. You calculate, this will be 10, this will be 0.2 L, right? This will become 0 because K आपका constant है. This, right? This will also become 0, right? And this will be only 2K. This is marginal productivity of labor. But the question में यहाँ पूछ रहा है, calculate marginal products of the input of the two inputs when 10 units each of labor and capital are used. So L is equal to 10, K is equal to 10. आप यहाँ पे वैल्यू को सब्स्टिट्यूट कीजिए. 0.2 into 10 plus 2 into 10, you get 10 minus 2, right? Plus 20, 2 into 10 is equal to 28. This is 28, you got the answer. Now you calculate marginal productivity of capital. Similarly, you will keep L constant over here. So this will be, when you calculate marginal productivity of capital, this will be your 0, this will be 15, over here it is, right? This will be 0.4K, over here minus 0.4K, and this will be plus 2K, 2L, sorry, plus 2L, right? Now you substitute the values when labor is equal to 10 and capital is equal to 10. When you substitute this, this will be 0.4 into 10 is 4, this will be 20, this is 31, right? Right? Now we move to the second part of the question. If 10 units of capital are used, what is the upper limit for the use of labor which a rational producer will never exceed? Only 10 units of capital are used. So, if 10 units of capital are used, हमारा production function जो दिया हुआ था, this was the production function. L के जगह पे हम 10 substitute, K के जगह पे हम 10 substitute कर देते हैं क्योंकि 10 units of capital है, right? यहाँ पर 15K है तो 15 into 10, 0.2K square है, right? So this will be 0.2 into 10 into 10, this becomes your 100, and so this is 2 into 10 L, right? What is the result? This will be 10L, this will be 0.1 L square, this will be 150, and this will be your 20, and this will be 20L. Now 10L, right, and 20L, this becomes your 30L, right? 0.1 L square, 150 minus 20, that becomes your 130. Now fine, this is now what you get. Q is equal to 30L minus 0.1 L square plus 130. This is what we have copied over here, right? Now you calculate delta Q by delta L. You differentiate, you get 30 minus 0.2 L. You are required to find L so that delta Q by delta L is greater than and equal to 0, right? This should be greater than or equal to 0. When you solve this, you get L, the value is 150. So the units of labor should not exceed 150. It should be either less than or equal to 150, right? It shouldn't exceed 150 units of labor, right? Now this is a question. Show that the production function x, function of labor and capital again, is equal to 2 under root LK, where जहाँ पर आपका x, L, K are units of output. x output है आपका, L labor है आपका, और K capital है. That you already know. It is giving you constant returns to scale. Scale का question है. और दूसरा क्वेश्चन बोलता है diminishing returns to inputs. ये दोनों कॉन्सेप्ट्स मैंने अभी आपको बताए. एक कांस्टेंट रिटर्न्स टू स्केल पूछ रहा है, दूसरा डिमिनिशिंग रिटर्न्स टू इनपुट्स पूछ रहा है, राइट? नाउ हाउ डू वी फाइंड आउट कि वेदर इट इज गिविंग अस कांस्टेंट रिटर्न्स टू स्केल या इंक्रीजिंग रिटर्न्स टू स्केल या डिक्रीजिंग रिटर्न्स टू स्केल, एंड हाउ इज इट गिविंग अस डिमिनिशिंग रिटर्न्स टू स्केल, राइट? फाइन, दिस इज द फंक्शन गिवन टू अस. फंक्शन labor in terms of labor and capital. Fine. Now let us find the degree of this function. The degree of the function will help us to find out whether it is giving us constant returns to scale or increasing returns to scale or decreasing returns to scale. So we multiply labor and capital by lambda. Lambda L, see over here function, lambda L into lambda K, right? This will be lambda lambda, that becomes lambda square into L by K, right? Take it out from the square root, we get lambda 2 under root LK. You find out that this is similar to the original function. So this is lambda F function of labor and capital. You see the degree is 1. The degree is 1. So this production function is homogeneous of degree 1, and hence it is giving us constant returns to scale. So the degree of the function helps us to determine the returns to scale, right? You have to remember this, that the degree of the function helps us to find out when it is 1, it will give us constant returns to scale. If it is more than 1, increasing returns to scale, and if it is less than 1, then it is decreasing returns to scale. Now the second part of the question is diminishing returns to inputs. Diminishing returns to inputs. Now in order to show that it is giving diminishing returns to inputs, how will you remember this? Inputs क्या क्या है? एक तो labor है और दूसरा capital है. इसका मतलब है मार्जिनल प्रोडक्टिविटी ऑफ लेबर निकालेंगे और मार्जिनल प्रोडक्टिविटी ऑफ कैपिटल निकालेंगे. अगर ये दोनों फॉल कर रहा है, इट इज लेस देन 0, राइट? इसका फर्स्ट डेरिवेटिव अगर ये लेस देन 0 है इन दोनों का, तो इसका मतलब ये डिमिनिशिंग रिटर्न्स टू इनपुट्स है. लेट अस सी नाउ. टू शो दैट द प्रोडक्शन फंक्शन गिव्स डिमिनिशिंग रिटर्न्स टू इनपुट्स, we will show that the marginal products of inputs are decreasing functions. और हमने ये ऑलरेडी किया है कि डिक्रीजिंग फंक्शंस कैसे प्रूव करते हैं. जब हम इन MPL और MPK का फर्स्ट डेरिवेटिव निकाल देंगे और इसको लेस देन 0 प्रूव करेंगे, तब ये प्रूव हो जाएगा कि ये लोग डिक्रीजिंग फंक्शंस हैं. सबसे पहले तो हम MPL निकालेंगे, राइट? MPL जहां पर आपका k कांस्टेंट हो जाएगा, that is delta x by delta L. This comes out to be under root k by L, right? Again we calculate marginal productivity of capital. This is equal to delta x by delta k, that is L by k. We have just calculated these MPL and MPK. We haven't proved it कि वो लोग डिक्रीजिंग फंक्शन है. इसको डिक्रीजिंग फंक्शन प्रूव करने के लिए इसको हम एक बार और डिफरेंशिएट करेंगे, राइट? अगेन वी डिफरेंशिएट MPL partially with respect to L, right? Again we differentiate this with respect to L, right? See, we are differentiating it. What we get is minus half under root k by L to the power 3 by 2. You see a minus sign over here? It is less than 0. If L is increased while k is held fixed, MPL will diminishing. ठीक है? Diminishing returns to input में एक आपका फिक्स होता है, इसीलिए the statement is like this. अगर L को हम इंक्रीज करते जाएंगे और k को फिक्स रखेंगे तो मार्जिनल प्रोडक्टिविटी ऑफ लेबर जो है वो हमारा कम होते जाएगा. उसी तरह हमें यहाँ पे प्रूव करना है, इसका फर्स्ट डेरिवेटिव निकालना है, राइट? मार्जिनल प्रोडक्टिविटी ऑफ कैपिटल का. We get this. So this is also a minus function, a negative. It is less than 0. So marginal productivity of capital is also diminishing, right? अगर k को increase करते हैं और L को fix रखते हैं तो marginal productivity of capital will diminish. Now next question. Function is given by q is equal to 27 L to the power 2 by 3. What is this? L to the power 2 by 3, and this is k to the power 1 by 3. Note this, L to the power 2 by 3 into k to the power 1 by 3, where L is labor and k is capital. क्या बोल रहा है क्वेश्चन में? आपको बिहेवियर पता करना है मार्जिनल प्रोडक्ट ऑफ ईच फैक्टर. बिहेवियर मतलब कि MPL एंड MPK इंक्रीज कर रहा है, डिक्रीज कर रहा है, कांस्टेंट है, क्या है? यू हैव टू फाइंड आउट दिस, राइट? दूसरा बात है नेचर ऑफ रिटर्न्स ऑफ स्केल. ये भी इंक्रीज कर रहा है, डिक्रीज कर रहा है, कांस्टेंट है, ये क्या है? यू हैव टू फाइंड आउट दिस. नाउ द थर्ड क्वेश्चन इज व्हाट इज द टोटल रिवॉर्ड फॉर लेबर एंड कैपिटल इफ ईच फैक्टर इज पेड अ प्राइस इक्वल टू इट्स मार्जिनल प्रोडक्ट. व्हाट इज द टोटल रिवॉर्ड ऑफ लेबर एंड कैपिटल? कितना रिवॉर्ड दिया जा रहा है लेबर एंड कैपिटल को? हमें अगर हर फैक्टर को उसके मार्जिनल प्रोडक्टिविटी के अनुसार अगर हम पे कर रहे हैं, तो अगर L पूरा लेबर L है और उसको उसकी कैपेसिटी उसके प्रोडक्टिविटी के अनुसार कर रहे हैं, तो दिस शुड बी डेल्टा Q इनटू डेल्टा Q बाय डेल्टा L. दिस इज व्हाट द क्वेश्चन इज सेइंग. यू हैव टू फाइंड आउट. प्लस व्हाट यू हैव टू डू, अगर कैपिटल को भी उसके मार्जिनल प्रोडक्टिविटी के अनुसार हम पे करें तो Q इनटू डेल्टा K इनटू डेल्टा Q बाय डेल्टा K. This is what you have to calculate over here, and you have to find out, right? So what is the question? Q is equal to 23. This question has come in BCom Honors 2009, right? So the question is Q is equal to 27 L to the power 2 by 3 plus K to the power 1 by 3. हम सबसे पहले MPL निकालेंगे. ये डेल्टा Q by डेल्टा L हो जाएगा, जहाँ पर हमारा k को हम कांस्टेंट मानेंगे. तो that comes out to be 27 into 2 by 3 करोगे आप. Ultimately you will get 18 L to the power minus 1 by 3. Again you will do here minus 1 to the power minus 1, right? You know this differentiation. K to the power 1 by 3. इसका नेचर पता करने के लिए हम इसको एक बार और डिफरेंशिएट करेंगे with respect to L. We differentiate this. What we get? Minus 6 L to the power 4 by 3 K to the power 1 by 3. That is less than 0 because we have a negative sign over here. So हमारा marginal productivity of labor decreases as L increases while K is held constant, right? Again we do the same thing for capital. हम MPK निकाल लेते हैं, जो हमारा आता है 9 L to the power 2 by 3 into K to the power minus 2 by 3. हम इसको with respect to capital फिर से differentiate करेंगे, and what we get over here is this minus 6 L to the power 2 by 3 K to the power minus 5 by 3. We have a minus sign over here, which is less than 0. Again, MPK decreases as K increases and L being constant. Right? This is what we have to do in the first part of the question. Now we move nature. Nature of returns of scale पता करने के लिए हम इसके डिग्री को निकालेंगे. डिग्री को निकालने के लिए हम क्या करेंगे? हम इसको लैम्डा से हर वेरिएबल को मल्टीप्लाई करेंगे. ओरिजिनल फंक्शन हमारा है 23 L to the power 2 by 3 into K to the power 1 by 3. हम lambda L to the power 2 by 3 किए, lambda K to the power 1 by 3 किए. हम open the brackets, we get lambda to the power 2 by 3, L to the power 2 by 3, lambda to the power 1 by 3, K to the power 1 by 3. lambda और lambda इनके पावर प्लस हो जाएंगे, बेस सेम है, right? So we get 27, right? So that will come out to be, this will be 3 by 3, so that is equal to 1. So lambda into L to the power 2 by 3, K to the power 1 by 3. Degree हमारा 1 है. See, we have a degree 1. So this is constant returns to scale. Right? Now, third part of the question we have already discussed over here. आप क्या करोगे? जो भी आपका ये आया, delta Q by delta L, delta Q by delta K, आप इसको value substitute करो and you get, and you simplify this, you will get 27 L to the power 2 by 3 into K to the power 1 by 3. That is equal to your original function, that is Q. So your total product is exhausted, right? Constant product curve or isoquant. What is the meaning of isoquant? Isoquant means equal quantity. Right? We have a production function which is a function of labor and capital. Okay. Certain combinations of labor and capital over here, look at this diagram. The y-axis tells you units of capital and the x-axis tells you units of labor. Certain combinations of capital and labor give isoquants. This is one isoquant. This is another, this is the third one, and this is the fourth one. This isoquant is this isoquant of 100 unit. It means that any combination of capital and labor, any combination of labor and capital, right, will give the same quantity, that is 100 units of output. If you use, that is OKL amount of capital and OL units of labor, right, this one, this, so this is the point over here. And even if you use, this is O K1 amount of capital and O L1 units of labor, it will give rise to the same output, to the same isoquant, that is 100. This isoquant will not change. This will be the unit, the total output will be 100 only. Again we move to the next isoquant, that is 200. What does it mean? Any combination of capital and labor, any combination, whether this is this combination, whether this is this combination, or whether this is this combination, right, it will give us 200 units of total output. Let us come to the properties. Similarly, these are 300 units of output and for the higher isoquants, right? Come to the properties of isoquants. The constant product curves or isoquants are downward sloping. As you can see from the diagram, they are downward sloping. They are convex from the origin to the origin. You can see from the diagram, they are convex. Concavity is this and they are convex, right? They are in this way. The constant product curves never intersect each other. This is one of the properties of indifference curve, as you know, right? And this is an isoquant. They do not intersect each other. They never intersect each other. And higher isoquants represent higher levels of output, right? So, see, this is 100. This is isoquant telling you 100 units. This is an isoquant 200. This is 300 and this is 400. Come to the question now. Question क्या है? Show that the isoquants generated by the Cobb-Douglas production function, the function is x is equal to a L to the power alpha into k to the power beta, are negatively sloped. Right? They are negatively sloped, and this is the first what you have to prove, and the second that you have to prove is convex from below. This was convex from below. You know these facts that they are negatively proved and they are convex from the below, but you have to prove these facts. Now what are the constants given in the question? Where a, alpha and beta are positive constants. Now how will you proceed with the question? This is a question of do you the University BCom Honors 2004. This is an important question. Right? Now how will you proceed? Suppose now if we find out delta x by delta L, that will give us the marginal productivity of labor. If we find out delta x by delta K, that will give us the marginal productivity of capital. So we do not have to prove that MPL or MPK is negative. But rather what we have to prove? We have to prove that dx is equal to, you know this is the equation of total differential, right? Dx is equal to delta x by delta L into dl, this is not x, plus delta x by delta k into dk. You have to apply total differential, and what you have to prove that this isoquant is negatively sloped. In order to prove that this is negatively sloped, you have to prove that dk by dl, that is the slope of the isoquant, dk by dl is negative. You have to prove this, and in order to get dk by dl, you have to use the concept of total differential, and you have to use the concept of this formula. From this formula you have to get dk by dl. So in this formula you have to find out this, that is marginal productivity of labor. You have to find the marginal productivity of capital, right? You also have to remember this, that dx is equal to 0 for movements along an isoquant. For any movement along an isoquant, since isoquant represent equal quantities, any movement along an isoquant is equal to 0. That is dx is equal to 0. This dx, this value, this dx is equal to 0. Right? Why total differential? The application of total differential is where there isn't any fixed variable, right? Everything is varying. All the variables are varying. There isn't anything. Partial derivative may, when you find out the marginal productivity of capital, then labor is fixed, and then you find out the marginal productivity of labor, then capital is fixed. But over here in total differential, the concept of total differential is applied. Why? Because all the variables, whether it is capital or labor, they are varying. They are not constant, right? So, and dx is equal to 0. Why? Because when you're different, these isoquants are representing varying levels of output. That is, this is 100, this is 200, this is 300, this is 400. When you find out the total differential, that you will get is equal to 0. So total differential of 100, 0, 200, 0, 300, total differential is also 0, 400 total differential is also 0. So dx is equal to 0 for movements along an isoquant, right? So we put that dx is equal to 0. See, we have put this here is equal to, our objective is to find dk by dl. So we will simplify this now. See, delta x by delta L into dl plus delta x by delta k into dk is equal to 0. Now what you do, you will take this term into this side, so it becomes negative over here, as you can see here, right? Fine. You will take this dl over this side and this one over to this side, right? What you get over here is this, delta x by delta L into delta k by delta x is equal to dk by dl. Now dk by dl is equal to negative of this, delta x by delta L into delta k by delta x. Now what you have to do, you have to find out these values, right? Marginal productivity of capital, marginal productivity of labor. Let us find out, and then we will put this over here in this formula. When we find out the marginal productivity of labor, we get this. This is the equation. So this alpha, we are differentiating with respect to L. So our K becomes constant, right? Our K will be constant. So this alpha will come over here, and then this will become alpha minus 1, and this is K to the power beta. Again, with respect to capital, so our labor becomes fixed over here, right? So this will be, beta will come over here, this will be as it is, and this will be K to the power beta minus 1. We substitute these values over here. Whatever we got, this is marginal productivity of labor, and this will be marginal productivity of capital. You cancel these things. This is common, right? Common cancel. You will alpha, L to the power alpha will be left with 1, that is L to the power minus 1 will be left over here, right? Okay. We cancel this K to the power beta, K to the power beta. Over here we'll be left with K to the power minus 1. Okay. Now what you are left with? You are left with only these terms, right, with a negative sign. So we write this over here, and then this will be K by L. As you can see, this is a negative sign which is less than 0. So this isoquant is downward sloping. So this is, now you understood, right? Now you have to prove that this is convex also. In order to prove that this is convex, again you double differentiate whatever you got in the first step, right? That is d square k by dl square. You double differentiate it, you take out the constants outside, and then you apply the formula u by v. And when you apply the formula u by v, you get what this is. This is alpha by beta square over here into k by alpha plus beta by l square, right? You see this is positive, it is greater than 0. So hence you have to prove this is greater than 0, and hence this is convex to the origin, right? Okay. This is our next topic, that is marginal rate of technical substitution. What is the topic? Marginal rate of technical substitution. This is also MRTS. मार्जिनल रेट ऑफ टेक्निकल सब्स्टिट्यूशन में क्या होता है कि हमारा जो आउटपुट है वो कांस्टेंट होता है. हमारा आउटपुट क्या होता है? वो कांस्टेंट होता है. यहाँ पर ये दिखाया जाता है कि इनपुट्स के बीच में रिलेशन क्या है. इनपुट्स क्या है? लेबर एंड कैपिटल हमारा इनपुट्स है. यहाँ पर लेबर एंड कैपिटल हमारा इनपुट्स है. इन दोनों के बीच में क्या रिलेशन है? मतलब अगर हम if we want to increase 1 unit of an input, so how many units of other input needs to be sacrificed to be at the same level of production, right? This is marginal rate of technical substitution. Let us see. The marginal rate of technical substitution of L, of labor for capital, which is denoted by MRTS, is defined as the number of units of K. How many units of K? कितना capital का units आप sacrifice करोगे? That a producer is willing to sacrifice. एक producer is willing to sacrifice for an additional unit of L. आप labor को बढ़ाना चाह रहे हो, मगर आपका output same है, right? Your output is same. You want to increase your labor, but your resources are limited. So you need to decrease your capital. So in order to increase 1 unit of labor, how many units of capital you will sacrifice so that your output remains, so as to maintain the same level of output. You have to remember this, right? So that you remain on the same isoquant, on the same quantity, right? MRTS between labor and capital is numerically equal to the negative of the slope of an isoquant at any point. You know the slope of an isoquant is dk by dl, right? And this is MRTS is equal to negative of the slope. So this is minus dk by dl, right? This is also equal to marginal productivity of labor by marginal productivity of capital. Look at the question. Production function for a commodity is x is equal to 2HLK minus AL square minus BK square. You have to find out at any point on constant product curve MRTS of L for K. right? Okay, this is the production function. Let us differentiate this. Delta x by delta k, right? This will be differentiating with respect to L, so our k will be constant over here, right? This will be 2hk and this will be minus 2al and this becomes your 0, right? Again we calculate delta x by delta k. This is what we will get, 2hl hl minus 2bk. MRTS कैलकुलेट करने के लिए मार्जिनल प्रोडक्टिविटी ऑफ लेबर और मार्जिनल प्रोडक्टिविटी ऑफ कैपिटल, आप इसको यहाँ पे फॉर्मूला में लगाओ. When you simplify this, you get the answer is hk minus al by hl minus bk. Okay. Elasticity of substitution. This is our next topic. The elasticity of substitution between labor and capital, which is denoted by this symbol sigma, is defined as the ratio of proportionate change in capital by labor ratio to the proportionate change in the marginal rate of technical substitution, MRTS. Again we read this. The elasticity of substitution between labor and capital, this is denoted by this symbol, is defined as the ratio of proportionate change in capital by labor to the proportionate change in marginal rate of technical substitution. So this is equal to d k by L ratio by k by L. This can also be written as percentage change in this ratio, k by L ratio. Look at this formula first. According to the definition, it means this is percentage change in k by L ratio by percentage change in MRTS, right? This is what the definition says, that the ratio of proportionate change in k by L to the proportionate change in MRTS. So we can say percentage change in k by L by percentage change in MRTS. Since this is percentage change in k by L, so this is d k by L by k by L into by d MRTS del by MRTS, right? This can be again written as d k by L ratio by k by L divided by d MRTS by MRTS. Again we do the reciprocal of this into MRTS by d MRTS. What we get over here, MRTS is also represented as equal to R, right? So you see this is as it is over here, see, right? MRTS को हम R भी लिख सकते हैं, तो हमने R लिख दिया, and over here this will be D and R, so this is dr, right? So again we rewrite the formula. This will be R into D k by L by k by L into dr, right? This is what the formula of elasticity of substitution is. Now the question is, for the Cobb-Douglas function, production function, which is Q is equal to A k to the power alpha into L to the power 1 minus alpha, you have to find the elasticity of substitution, right? By using this formula, you have to find the elasticity of substitution by using this formula. It's given to you that you have to use this formula. This question has come in Delhi University BCom Honors 1984. It means what you have to do, you have to find out delta Q by delta L, right? You have to find out delta Q by delta K, right? Again you have to find delta square Q by delta L into delta K. This is so simple. Now see, this is what we have calculated here, delta Q by delta L, right? This is what we get, 1 minus alpha A k to the power alpha L to the power minus alpha. This is delta Q by delta K, alpha into A k to the power alpha minus 1 into L to the power 1 minus alpha. Again, in order to find this, right, we differentiate over here, delta by delta K into delta Q by delta L. So this will be This is the answer. You substitute the values, you get that is equal to 1, right? This is the elasticity of substitution for this. Okay. For today, we'll be doing our next topic in the coming videos. Thank you so much.